Well, hello everybody. We are going to analyze in this video the Maricopa County 2020 presidential election results. And let's talk about our data. I got my data from the Maricopa County Elections Department. You have the link up here, and I point to the text file that has it all. My next step, after downloading the text file, was to check how many precincts there are, and at this link I saw that the precincts were numbered from 1 to 748, but it turns out a few of the numbers are not used. So let's go and get our data. We'll do it all in Excel. So we will do data, get data from text, and I've already downloaded the data. This is the data. Import. Got a bit of work to do. Load. Getting data, 120,000 rows, 155,000 rows. There are only two presidential candidates that we are going to analyze, and we only have 740 something precincts, so we don't need all of this data. The first step is some data cleansing. I don't need these fields that have data that simply repeats itself all the way down the column. So we can go delete. And I start with my important precinct ID. I also don't need precinct status. I don't need candidate type. And I don't need the last four fields, which leaves me with a very nice 26 fields all the way from A to Z, or as I would say, A to Z. Now, what I see is that Trump, Pence, and Biden, Harris are candidate IDs 1 and 2. I don't need all the rest of the candidates. So what I'm going to do is I'm going to sort so that these 1s and 2s are together. Then I'm going to delete what I don't need. So let's go home, sort. We'll do a custom sort, and we will sort by candidate ID, smallest to largest. Now I have all my Trump Pences together. And somewhere around here, let's find it, I have this row which I don't need, and I can delete it now. Delete. And now we move to Biden-Harris, and we'll go all the way to 1400 and change. What I don't need are all these rows below, including this odd row here. And I would do a right click and delete. But that's going to take a long time, so you can highlight many numbers at a time to right click and delete, and you'll delete everything that you don't need. I've already done that, so I'm going to simply close out of this file, don't save, and I'm going to go back to this file, Trump Biden only, which is the file after I deleted the fields I don't need and the rows that I don't need. So the first thing we're going to look at are the precinct registered. And indeed, if the number of registered voters per precinct, if that follows Benford's law, then the Trump and the Biden numbers should too. So let's just find out again. This is column E, and we end in, let's see where we change over. We end at row 744. There we go. 744. So I'm going to do go to, I'm going to highlight F5. Go to. And it's E2 to E744. I've got all the numbers. If I go down to Biden-Harris, this pattern simply repeats itself. So we'll do copy, and I'm going to go to my Negrini cycle folder, and I've already opened the file and I've renamed it Benford Precincts, and I will give you a link to this file. It's free software, it works well, don't have to register. There we go. Now, I'm not so much interested in the last 2 digits. For a small data sets like this, I'm interested in the last digit. So I'm going to change that to a 1, which gives me the rightmost 1 digit. There we see it's picked up the last digit. And over here it's telling me the last digit there is an 8, which indeed it is. I need to copy this down to the last row, get the plus sign, hold it, and swift left, double click, and it's all copied down. So we have the first digit of each number, the second digit of each number, the first 2, the last 2, which are the cents. I don't have cents, so that's all 0, and the units over there. Let's go have a peek at the last digits. They go from 0 to 9, and well, we can see they're not all at exactly 10%, but close enough. First digits, they do not follow Benford's law. This is the Benford line. First digit 1, 30.1%, 17.6, 12.5, all the way down to 4.6%. This is the Benford line. These are the actual proportions, and here the actual proportion is way below Benford. There the actual proportion is way above Benford. This is not Benford compliant. Let's go have a look at the mean absolute deviation, and that looks like 0.056. So this is telling me that on average the actual proportion is 5.6% away from the expected proportion. It could be under, it could be over, but on average we're 5.6% away, which is awful. So let's do a little Word document. Let's get this all neat. I've already done this analysis before. I didn't just come here unprepared. So here we go. Oops, that was something else that I was doing earlier on. That was Apple. So let's move a little bit before Apple. There we go. We'll do copy. We'll go to our Word document, registered voters, and the mean absolute deviation was 0.056. I'm going to paste that graph in there. There we go. Let's bring it down to size a little bit, and let's bring it down to 40%. Darts players love the number 40. So, now, here's the rub. Because the number of registered voters does not follow Benford's law, I should not expect the Trump or the Biden counts to follow Benford's law either. Indeed, this is why it would follow Benford's law if the registered voters did follow Benford's law. If that data set, this one here, if it followed Benford's law, and indeed approximately 35% of those voters voted for Mr. Trump and 35% voted for Mr. Biden, it would be like taking these numbers and multiplying them all by a constant, in this case 0.35. And if my source data follows Benford's law, and I multiply all those numbers by a constant, the resulting data set will also follow Benford's law. However, if my source data doesn't follow Benford's law and I multiply all these numbers by a constant, the new data set is not going to follow Benford's law. It could be worse, it could be better. Let's go have a look. Let's have a look at Mr. Trump's numbers. So, his total votes, amazingly, are in a field called votes. And there we go. He is all the way from R to R744. So let's go F5, go to R2, I'm there already, to R744. Okay, right click, copy. Now I have the file open, I've already prepared it, and I can go right click, paste. I don't really want the last 2, the data set is too small. If I change this to a 1, I get the last digit, and you can check it works. And now I need to copy these formulas all the way down to the last row. Plus sign, swift left, a double click does it. Let's have a look at the last digits. Lots of eights. Lots of eights, but that by itself doesn't shout out anything too terrible. Might just be by chance. It should be 10% of all numbers ending in 0, 10% of all numbers ending in 1, 10% of all numbers ending in 9. The reason that it's all 10% is because the last two digits there, the expected proportions are equal. Aha, we were all waiting for the first digits. There they are. This isn't too terrible. In fact, this is a better fit than the precincts. I need to go here and raise this, format the axis. I need to raise this to a maximum of 0.6. Okay, that's because I need to go to 0.6 for Mr. Biden's graph. So, this isn't too terrible. You can see right over here we have very small deviations. In fact, from here to here, a small deviation. Here, a little bit. And let's go have a look at the mean absolute deviation, much smaller, 0.024. So on average, we're 2.4% away from Benford's law. And again, these are the Benford proportions, 30.1% for the first digit 1, 17.6% for the first digit 2, 12.5% for the first digit 3, all the way down to 4.6% for the first digit 9. I am off by 2.4%. So, this isn't too bad. I am actually quite surprised. So we can go here, and I've already done this, so we'll take this here, we'll do a copy, we'll go to the Word document, Mr. Trump's first digits, and his mean absolute deviation is equal to 0.024. We go, make it all the same, put an equal sign there. And we'll go Control V for paste. And there he is. And let's take the size down to 40%. Again, darts players love the number 40 when they're playing 501. And we'll do this. Now, let's go have a look at Mr. Biden's digits. I go back to my source data. And Mr. Biden's numbers are in R745 to R1487. So we're going down here. I don't know, I don't actually need to scroll down. We can go F5, which is go to R745 to R1487. And we'll do OK. Copy. Go to the Negrini cycle template. I've renamed it, but here it is. Paste. I want the last digit, so we have to change this to a 1. I don't want the last 2. They're not enough numbers. Plus sign, little double click. Highlight, get the plus sign. There she is. Little swift left, a double click. It's copied all the way down. I'll keep you in suspense. Last digits. Pretty nicely clustered around 0.1. No, nothing looks too terrible. A little short of 6s here. I can live with it. But watch the first digits. A much weaker fit than Mr. Trump. And indeed, these axes are now calibrated the same. If I go to this mean absolute deviation, it is 5.4%, 0.054. So I can go mean absolute deviation equals 0.054. And this is approximately equal to this mean absolute deviation, although the pattern is different. I'm going to go, and we can do, this is Mr. Biden, first digits. I can do a copy here, but I've already done this. in Snagit. We'll do copy again, back to Word, Control V, change the size so we can get everything on one page. And here we go. The source data. The precinct total voters did not follow Benford's law. I did not expect either of these counts to follow Benford's law. However, Mr. Trump was surprisingly close. And indeed, the cutoff is actually 0.015. If the mean absolute deviation is greater than 0.015, our conclusion is non-conformity. So in both cases it is higher, in all three cases it's higher, but it is rather interesting that this is the best fit. Now, there are some other cases or some other tests. Let's go and have a look and see whether Mr. Trump has got an inordinate number of low votes. So now I'm going to resort this data, sort, custom sort, and I'm going to sort it by candidate ID first, keep all the ones together, all the twos together, and then I'm going to sort it by votes, smallest to largest. And when I do this, I see that Mr. Trump has got about 20 precincts with counts below 100. If I scroll down to Mr. Biden, I see that he also has about 20 precincts with votes below 100. So that was a rather simple test. Neither candidate has got an inordinate number of small votes. But let's go do one more test. I'm going to look at the correlation between the numbers county by county. I need to do a sort first, otherwise this test isn't going to work. I need to sort, let's go back up here. I need to sort first by candidate and then by the precinct ID. So we'll go home, sort and filter, custom sort. First by the candidate ID, keeps the ones and the twos together. Then by the precinct ID. And what this means is that the first row for Mr. Trump is the same precinct as the first row for Mr. Biden. Second row for Mr. Trump is the same precinct as the second row for Mr. Biden, all the way through. Okay. And now I'm going to go do the correlation here, and we can do equals correlation. And the Trump numbers are in R2 to R744. And the Biden numbers are in R745 to R1487. You can't have a mismatch here. And we'll do enter. And watch that number. It's a bit difficult to see. I'm going to format it down to 2 decimal places. And the correlation is a positive 0.6. This means that in general, a high number for Mr. Trump is matched with a high number for Mr. Biden. But that is just in general. If we wanted a really tight fit, high numbers for Mr. Trump would be closer to 0.8 or 0.85. So it's positive, it's high-ish, but it's not perfect. So those are the tests that I want to do now. Let's just go back to the PowerPoint and do a little bit of self-promotion here. This all comes from my book, Forensic Analytics, but watch, the second edition came out in 2020. The first edition is almost a halfway completely different book. Let's just go here. In chapter 2, I talk about chapter 1, the main steps, and there I talk about data cleansing, which is what I did in the beginning when I got rid of all the fluff that I didn't need. In chapter 2, I talk about a histogram, and we could actually use a histogram to see what the distribution is for the number of voters per precinct. That would help. Some early discussions of Benford's law, I talk about scale invariance here, and this is the case where if the precinct number of registered voters followed Benford's law, then I should expect the Trump and the Biden accounts to also follow Benford's law. Here I talk about the mean absolute deviation, which is how I measured my conformity to Benford's law, and you saw I have a table there and everything. Using correlation to detect fraud, you saw I did the correlation test. I speak about it more in the book here. And interestingly enough, in chapter 10, I analyzed Joe Biden's tax returns. I find nothing wrong. I wasn't expecting to find nothing wrong, President Biden, but I did have a look, and that analysis is there. So, if you like this, let me know. I'll go do Milwaukee County for you tomorrow or on Thursday when I have some spare time. And if you have some spare time, go to my website. I talk about my book, Forensic Analytics, the data sets, videos, lots of things. You don't have to register. It's free. I have a Benford's Law page. I have YouTube videos. I have a blog. My latest post was on Apple, but I've enjoyed this for you today. So if you like this video, please click like, and let's talk about Milwaukee County maybe tomorrow or later this week. Bye now.